This video is going to cover how to cut and hold down small parts if you are dealing with or working with warped material or you just don't have enough vacuum. I recently visited a cabinet shop to help train and set up a machine for cutting cabinet components, and we had a sheet here that had a lot of small parts on it. Not only were the parts small, we were working with single-sided or laminated material only on the one side that caused that plywood to really warp. As you can see here, the vacuum is turned on, but the way this was warped, we just could not hold this down or get that pulled down in a way, even though we had two very large Becker vacuum pumps. We did manage to get all of this cut out and these parts cut out without any clamps or mechanical fasteners. We only used the vacuum and strategy in cutting these parts. So we're going to focus on both the strategy of cutting this along with the order that we cut out and the plunge points that we're going to use. So I don't have that exact job, but I've kind of duplicated a job that may present some problems in part hold down, especially if we are warped up and we don't have a good vacuum on the upper side of this sheet. When cutting parts or a sheet that has a lot of small parts, you want to start with the smallest part first, move on to the biggest one. That most people understand that and get that. What a lot of people don't focus on is the plunge points or where the starting position of that cut is going to be. So we're going to focus on that and also use the onion skin option. So let's set the onion skin option first, just because that is really the easiest. So we're going to go to the operation of this cut, 7.5, which is the perimeter cuts we have set to be on the outside. I'm going to set the option to use onion skinning for this sheet. Saving that as a template. Now coming back up into tools and then settings, we're just going to look at what the onion skin settings are. So here we have an onion skin of 0.03. It's a 32nd of an inch. This is how deep it is going to go, or how much of a skin it is going to leave. So our total cut depth here is 0.75. We're not going to cut down that deep. We're going to cut 30 thousandths less. And we're also only going to onion skin or apply that onion skin to parts that are 400 square inches or less. So just remember that setting, and you don't have to set it again now that we've saved this as a template. We don't have to check that box again. It'll be there for the next time we use it. So that is one method of part hold down. The second is the strategy of what parts get cut first and where the plunge points happen. So by default, all of the parts, small parts, are going to be cut first, but not necessarily in a order that is going to aid in part hold down. So we're going to change that order around, and to do so, we're going to click this option over here that says cut order. Once we set a checkbox there, we get a little red circle with a number inside of that circle. The circle is indicating where the plunge point is going to happen first, and the number inside of that circle is the order of cut. So we have a 1, 2, kind of bounces around on some of these small parts. We want to set a more logical order to this. We are using a conventional cut that is a left to right motion or a counterclockwise motion around the outside of the part. If in this case, if we had this part that is being cut, as it plunges in and makes its pass to the right, up, and then back to the left, once it gets to this location here, that part has now been removed from the rest of the sheet. So as it's cutting down this direction, the only thing that is really holding that part in place is the surface area or the weight of air above that part. So we want to change that plunge point around. So if we started the plunge point in the bottom right, so as it cuts up, goes to the left, comes down, as it's making this pass here, we are still attached to the majority of the board. So if it's going to kick, the only time that is going to get kicked off is when it makes its last little release cut right here on the lower right. We also are going to set the order. So think about this part, dividing it into 4 sections, and I'm going to click on the section where I want the plunge point to be, and I'm also going to click in the order that I want them cut. So the strategy here is to click each part on the sheet in the order that we want it cut. And if we do that, the part that we click first becomes the part that is cut first. Another way to think about it is the part that we click on last is the last part that gets cut. So if I click on this part right here in the lower right section, we see that plunge point gets moved, and then that number gets to be a number 23. Clicking on this next part, that 23 is going to come down to a 22. This 4 is going to become a 22, or the 23. So you can see the cut order is changing with every time we click. So I'm going to just go through and click the lower right of every one of these parts. And as we get all the way down to the last of them, the larger parts, I'm not as worried about it because I'm certain the vacuum is going to be good enough to hold those parts down. I'm just clicking in those orders there. So now if we look up at the top, we can see they are ordered in the order that we click. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. By setting this order, again, we're working from the top of the sheet downwards and keeping the part attached to the majority of the sheet as long as we possibly can. Now, the onion skin is also going to aid in this operation. The onion skin is only going to be applied to these smaller parts here because they are under 400 square inches. The parts on the bottom side are larger than 400, so those will not get an onion skin. So the way the onion skin is going to work is it will go through and cut all of these smaller parts almost all the way through. It's going to leave just 30 thousandths material left behind. Once it gets down to this part here, it's going to come back up to the first part again, cutting full depth down to the 0.75, 755, or however much you've added to the depth of that cut, and work its way down below. Now, even though these parts are small, the vacuum is still somewhat solid because we haven't broken through into that vacuum layer yet. And now when we're removing this onion skin, there isn't a whole lot of material there. There's not a whole lot of cutting force that's being applied here because we're only removing 30 thousandths of the material, and that's less than the thickness of that laminate or a ply. So we will do a pretty decent job of holding all of these parts down without the need of a very strong vacuum, or if we had a warped piece of plywood, that will pretty confident that we would have success in cutting these parts out. Worst case that you have in holding these parts down is the last little bit that gets cut here when it's removing that last little bit of onion skin. That part might kick just a little bit, which is going to leave a little bit of an arc cut or a tab there, and that's only going to be on the onion skin thickness. So at worst case, you're going to have a little, like, kind of called a ski jump there right at the end of that part. So hopefully this is going to help you hold some of your smaller parts down, and good luck, and look forward to hearing if this method and strategies work for you.